An indeterminate limit is a limit that requires us to do some algebra before we can determine the value of the limit. There are many forms of indeterminate limits, such as 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, and there are more. But we're going to focus on 0 over 0 limits because those are the most common and they're the ones we need to solve in order to find derivatives. We're going to look at 4 cases. You can watch me solve an example for each case, but I'm going to talk more generally about the approach to solve each case. So case 1 is a polynomial on the numerator and denominator, and when we get 0 over 0 in this case, we need to factor the polynomials and cancel out common factors. Most of the time these are quadratics, but sometimes there are higher order polynomials in which we'll need to use our algebra 2 knowledge to factor. Second case is when we have square root in either the top or bottom. In this case, we need to multiply both the top and bottom by the conjugate of the square root. Remember that if we have something of the form square root a plus b, then the conjugate is square root a minus b. And conjugates work both ways, so both are conjugates of each other, so whichever one we have, we just multiply by the other. And remember that we can't just multiply by a new quantity in a limit, so we have to multiply the top and bottom by the same thing so we don't change the value. When we multiply something by its conjugate, we're going to have to FOIL it out like a quadratic. If we did it right, all the square roots will end up canceling out after we FOIL. Also note that we aren't distributing the bottom because distributing won't simplify anything. Instead, we keep the bottom as multiplication, and when the top is simplified, it is going to cancel out with part of the bottom. Third case is when we have a fraction in either the numerator or the denominator, which means we have a fraction inside a fraction. The goal here is to combine fractions. We need to recognize the correct order of operations, which is to first make the numerator and or denominator a single fraction with nothing else by doing fraction addition or subtraction, and then to divide the fractions in the top and bottom using fraction division. The last case we'll look at is trig limits. There are a couple important trig limit theorems that say limit as x goes to 0 of sine x over x is 1, and that the limit as x goes to 0 of 1 minus cosine x over x is 0. Usually we aren't given these limits exactly. There's usually some additional algebra or trig identities we have to apply first. But anytime you get an indeterminate trig limit, you should be aiming to simplify it into one of these two limits. In this example, I am showing all the algebra behind solving the limit. But if we understand how it works, we can get the answer directly from the problem by looking at the ratio of the coefficients.